this is Y.Renuka from 2nd UCC and my roll number is 19BQ1A04H5 and I am here to discuss about analog and digital communications, and my topic is about modulation and its types. Modulation, the process of changing the characteristic parameters of the carrier signal with respect to the instantaneous amplitude of message signal is known as modulation. And we have different types of modulation techniques. They are continuous wave modulation and pulse modulation. In continuous wave modulation, we have amplitude modulation and angle modulation. In amplitude modulation, we have double-sided band full carrier or conventional AM, and double-sided band suppressed carrier and single-sided band suppressed carrier and V-station sideband carrier modulation techniques. And in angle modulation, we have frequency modulation and phase modulation. When it comes to frequency modulation, we have another two different techniques known as wideband frequency modulation and narrowband frequency modulation. And in phase modulation, we have wideband phase modulation and narrowband phase modulation. When it comes to the amplitude modulation, the process of changing of amplitude of carrier signal with respect to the instantaneous amplitude of message signal is known as amplitude modulation. And here we represent message signal as M of t and carrier signal as C of t. We have three different types of message signal, namely single tone signal, multi-tone signal and arbitrary signal. When it comes to the single tone signal, the equation of M of t is M of t equals to AM cos 2 pi FMT, where AM is the amplitude of message signal and FM is the frequency of message signal. When it comes to the multi-tone signal, we have M of t equals to A1 cos 2 pi F1t plus A2 cos 2 pi F2t plus A3 cos 2 pi F3t and so on. When it comes to the arbitrary signal, we don't have any particular equation for the message signal and we represent it as M of t. And when it comes to the carrier signal, C of t equals to AC cos 2 pi FCT, and where AC equals to the amplitude of carrier signal and FC is equal to the frequency of carrier signal. And after the process of modulation, we get a signal named as modulated signal, and the modulated signal is represented as S of t. The equation of S of t in terms of single tone signal is AC into 1 plus mu cos 2 pi FMT into cos 2 pi FCT, where mu is the modulation index. Greater than 1, it is known as over modulation, and mu equals to 1 critical modulation, and mu less than 1, it is known as under modulation. And now angle modulation. The process of changing the angle of the carrier signal in accordance with the amplitude of the message signal is known as angle modulation. In angle modulation, we have two different types of modulations, namely frequency modulation and phase modulation. When it comes to the carrier equation in angle modulation, C of t is equals to AC cos theta of t, where theta of t equals to 2 pi FCT plus phi, where FC is the frequency of carrier signal and phi is the phase of the carrier signal. And now frequency modulation, the process of changing the frequency of the carrier signal with respect to the instantaneous amplitude of the message signal is known as frequency modulation. And after the frequency modulation, we get the frequency of carrier signal as Fi, which is known as instantaneous frequency of modulated signal. The equation for Fi equals to Fc plus Kf M of t, where Kf is the frequency sensitivity of the signal, and delta F is equals to Kf into mod M of t, where delta F is the frequency deviation. And now the phase modulation. The process of changing the phase of the carrier signal with respect to the instantaneous amplitude of the message signal is known as phase modulation. And before the modulation, the C of t is equals to AC cos 2 pi FCT plus phi is the equation for carrier signal, and after the modulation, we get the equation for carrier signal as AC into cos 2 pi FCT plus M of t plus phi, where M of t is the message signal. Our subject is DSD using VHDL, and my topic is loop statements. Loop statements. The important class of sequential statements is loop statements. The simplest form of loop statements has syntax and creates an infinite loop. The loop statements is used to iterate a set of sequential statements. The syntax of loop statement is loop label, iterative scheme loop, sequential statements, end loop, loop label. There are three types of loop statements: for, while and next. For loop. The most familiar and one have seen before is loops. First, for loop. The syntax of for loop is mentioned, and note that the variable and the loop identifier, a loop variable and the identifier must be declared explicitly by its appearance in the for loop and is as same as the range loop. And the variable can be used within the sequential statements, which takes the values over the set of statements and moves from left to right for each iteration. The syntax of for loop is for identifier in range loop, sequential statements, end loop. While loop. The task kind of loop statement is known as while loop. In while loop, we use a Boolean expression which is tested before each iteration only to execute the iteration. That is, if the Boolean expression is true, then only the iteration continues. Otherwise, it exists. The syntax of while loop is while, Boolean expression, loop, sequential statements, end loop. And now exit. The exit statement is a sequential statement which is used inside a loop. And the exit statement is used to jump out of the inner loop without continuing the next statement. That is, the exit statement is used to exit out of the loop if the loop is specified. And when clause is used, the specified loop is terminated. And if no loop is specified, it exists from the innermost loop. And if the loop is specified, it exists of the specified loop. And only when the condition is true. And if the condition is false, the execution continues with the next statement. The syntax: next, exit, loop label, when condition. Next statement. The next statement is also a sequential statement which is used inside a loop. The syntax of next statement is same as syntax of exit statement, where the next keyword replaces the exit keyword. In spite of terminating from the loop, using the next statement, we can skip the statements of current iteration, and the execution resumes from the first statement of the next iteration. That is, if we use the next statement, we can stop some statements of current iteration to be executed, and the execution continues from the next iteration. If no loop is specified, the innermost loop is assumed. In exit, we completely terminate from the loop, but by using next statement, we just terminate from the iteration and the execution resumes from the next iteration. The syntax of next statement is next, loop label, and when condition. After, VHDL allows us to take a time delay using the keyword after. It is used for signal assignment statements including concurrent, conditional, specified, and selected assignments. That is, for example, z less than or equals to 1 after 4 nanoseconds when x equals to 1 and y equals to 0, else 0 after 3 nanoseconds. This allows us to inhibit a gate that has 4 nanoseconds of delay for 0 to 1 transition and only 3 seconds of delay for 1 to 0 transition. Wait, it is also a sequential statement by using which we can stop the statement to be executing for a period of time. There are 3 types of wait statements: wait on sensitivity list, wait until Boolean expression, and wait for time expression. Example: wait on a comma b comma c semicolon, wait until a equals to b semicolon, and wait for 10 nanoseconds. My seminar subject is control systems and my seminar topic is time response analysis. First of all, the definition of time response. The definition of time response is nothing but the output of the closed loop control system in terms of function of time. That is, C of t is equals to CTR of t plus CSS of t. CTR of t is transient response and CSS of t is the steady state response. And now, to calculate the transient response is nothing but the part of the time response that goes to 0 when the time t tends to infinity. That is, limit t tends to infinity, C of t equals to CTR of t. And the other name of transient response is nothing but dynamic response. The steady state response of the time response is nothing but the remaining time response after the transient response has died out. That is, the steady state behavior always varies in a fixed pattern such as sine wave or ramp function, which increases with time. In feedback control systems, it has an inherent capability to that its parameters can be adjusted after the transient and steady state behavior is done. In order to analyze the transient and steady state behavior of the control systems, the first step which is we have to obtain the mathematical model of the control system. By the use of final value theorem, the steady state response of simple deterministic control systems can be obtained. Before going to the time response analysis, we have to check the stability of the control system. The stability of the control system can be obtained using an indirect test without producing the transient response analysis. If the system is unstable, no need to go for the transient response analysis. In many of the cases, the actual inputs of the control system vary in random fashion with respect to the time. For the purpose of analysis and design, it is necessary to assume some basic type of signals so that the performance of the system can be evaluated. The characteristic terms of the control system that severely strain a control system are a sudden change, a sudden shock, a constant velocity, and a constant acceleration. Dynamic behavior of system for analysis and design is therefore judged and compared with some basic type of signals such as impulse, ramp, parabolic, and step. For step function, r of t equals to a into u of t, and where u of t equals to t for t greater than or equals to 0 and 0 for t less than 0. That is, r of s equals to a by s. And for ramp, r of t equals to at for t greater than or equals to 0 and 0 for t less than 0. r of s equals to a by s square. And for parabolic, r of t equals to a t square by 2 for t greater than or equals to 0 and 0 for t less than 0. r of s equals to a by s cube. And for impulse, delta of t equals to infinity for t equals to 0 and undefined for otherwise. That is, delta of s equals to 1. d by dt of parabolic is ramp, d by dt of ramp is step, d by dt of step is equals to impulse.